Hi and welcome to video 2 for section 1.7. This is the second of 3 videos. Again, like I told you in video 1, the end of video 1, originally I was only going to make 2, but there's going to be 3 now. So this is the second one. This is solving an inequality with a quotient or with a fraction. So, there's 4 steps that we're going to follow through here. Step 1, move all the variables and numbers to one side. So, i.e., the right side must be 0. If it is not, you cannot start this problem. You have to move everything first. Once you do that, go ahead and, if possible, simplify if possible. But the main thing is get everything over to the left side, 0 on the right. You're just going to be adding or subtracting everything off. Step 2, find the intervals. And as we do an example, you'll see how this kind of works out. But find intervals by setting both So by setting both the numerator and denominator equal to 0, separately. So all the different numerators, if there's a variable in it, we'll set that equal to 0. If all the denominators, if there's a variable in it, we're going to set it equal to 0. That's going to give us our interval points for our table, which is step 3. We're going to create a table. To determine the signs of each interval. And then 4, determine which intervals make the equation that we created in step 1, make that equation true. So again, go ahead and write this down. I would absolutely put this on your cheat sheet. And then we'll look at an example here. So, what if I have the following example? 1 plus x over 1 minus x is greater than or equal to 1. So everybody's first instinct with these kind of problems, and I probably shouldn't show you because I don't want to make it your first instinct, but because so many people do, that's why I'm showing you this. The first thing people always like to do on this problem is say, oh, I'm going to multiply both sides by 1 minus x. So I get 1 plus x is greater than or equal to 1 minus x, and then they solve for x and get an answer. Can't do that. First of all, what? It's an inequality of the quotient. I have a fraction here. But why can't I do that? Think about what we know about inequalities that would say, nope, you're not allowed to do that. Well, is 1 minus x positive or negative? I don't even know what the value for x is yet. So if x is 3, what do I have? 1 minus 3, that's negative 2. So when I multiply both sides by that, what do I have to do? I have to switch this inequality. What if x is 0? 1 minus 0 is 1, so I'm multiplying both sides by 1, so that's fine. So I didn't have to switch the sign. But the problem is what? I don't know what x is. So I don't know if I have to switch that sign or not. So that right from the start should tell me I can't use this method because I get to a point where I'm not even sure what I should do with the inequality sign. So you can't do that. You cannot, if you have inequalities with quotients, you can't just cross multiply and solve it. That's not how inequalities work. We have to follow this process. So step 1 is we have to move all the variables and numbers to the left. So if I do that, what do? I subtract 1 from both sides. So I get 1 plus x over 1 minus x minus 1 is greater than or equal to 1 minus 1 is 0. I have to have 0 on that right side. Now, we're at it. Simplify if possible, or i.e. combine the fractions. Because again, I'm going to have these quotients, these fractions. So to combine these two, what do I have to do? I have to have this with the same denominator. So I have what? 1 plus x over 1 minus x minus, and if this is going to have the denominator of 1 minus x, it's what? 1 minus x over 1 minus x is greater than or equal to 0 still. So the denominator is 1 minus x, and this is what? So 1 minus 1, that's 0. X minus a negative x is x plus x. X plus x is 2x. Is greater than or equal to 0. So that was step 1. That was a lot just for step 1. Move everything to the left, 0 on the right, simplify it by combining. Step 2, I need to find my intervals for the table I'm going to build by setting the numerator and the denominator equal to 0 separately. So 2x equals 0, 1 minus x equals 0. Solve these means what? X is equal to 0. And if I bring the x over, 1 is equal to x, which is the same thing as saying x is equal to 1. That was step 2. Set them separately, solve them to find my value for x, to find my intervals. Create my table. So my numbers range from what? Negative infinity to positive infinity. So I'm going to go negative infinity up to 0, up to 1, up to positive infinity. And where I have these values that I found, these intervals, I'm going to draw vertical lines on my table. Those are my breakpoints, if we want to call that. So now that I have these breakpoints, I want to look at the numerator separately, the denominator separately, and what happens when I do them together. That's number 3. So for 2x, let me draw a line here so we don't get confused. In the interval, negative infinity to 0, is 2x a positive or negative value? I don't really care what its value is, but I just want to know if it's positive or negative. So what I suggest doing is pick some numbers in here. What's the number between negative infinity and 0? How about negative 10? How about between 0 and 1? Well, let's go with a half. How about from 1 to infinity? Let's go with positive 10. So if x is negative 10, 2 times negative 10 is a negative number. It means in this interval, the numerator, the 2x, is negative. If x is positive half, this is positive. If x is positive 10, this is positive. Now I want to look at 1 minus x. So in this interval, if I plug in -10, 1 minus a -10 is like 1 plus 10, which is positive. 1 minus a half is still positive. 1 minus 10 is negative. So that's my numerator, that's my denominator. So how about when they're both happening at the same time? So 2x divided by 1 minus x. So what do I have here? I have a negative number over a positive number. Negative divided by positive is negative. Positive divided by positive is positive. Positive divided by negative is negative. And this should happen. See how we go negative, positive, negative. If I had a bunch more intervals, it would keep changing. Positive, negative, positive, negative, positive, negative. That bottom row, it should alternate from plus, minus, plus, minus, plus, minus. If it doesn't, you've probably got your breakpoints wrong, or you've got one of your interval signs wrong. Because that bottom row should alternate back and forth, back and forth, back and forth. Now, that was step 3. Lastly, step 4, determine which intervals make the original equation true. So my equation here, so this was step 1, this is the equation I'm worried about. So I want to know where is 2x divided by 1 minus x greater than or equal to 0. That means what? That means this thing is what? Positive. Where is this fraction positive? Well, right here. So that interval is what? From 0 to 1. If I wanted to know where is this negative, then it would be what? Negative infinity to 0, and then 1 up to positive infinity. So I'm not quite done yet, because I still need to figure out, I know the interval is 0 to 1, but is it parentheses or is it a bracket? Well, what do I want? I want greater than or equal to 0. So if I plug in 0, I'm going to test the endpoints. Can I plug in 0 into this equation? Well, that's 0. 1 minus 0 is 1, so that's fine. I don't have to worry about the denominator being 0. So it's okay if I include 0. But can I include 1? And the answer is no, right? Because if I plug in 1, that makes this denominator, 1 minus 1 is 0, undefined. So my interval is 0 to 1. 0 is included, 1 is not, and that would be my answer. Any of these numbers I choose will make the original one true, but it's based off of all this work getting this guy set with 0 on the right side. So that's it for video 2. That's how you're going to solve every single one of these types of problems. I know it's going to give you trouble. I know this already. So if you're struggling with it, don't worry. I guarantee you the majority of your classmates are too. So we'll work a bunch of these in class. Give it a try. Maybe pick some of the earlier numbers that might not be quite as complicated, the process setting up the intervals and so forth. Give it a try, see what you can do, and then when you come to class, just have it written down which ones you want to look at, and we'll try and get to as many as we can. So come on back and we will look at video 3, the third and final video for this section.